All right, we have two more formulas in this section. They deal with finding the area of a triangle. And again, we're used to the normal formula that the area of a triangle is 1/2 the base times the height. And probably in most previous math classes you did that and were given either the base or the height, or you could figure it out quite easily. Well, now that we have trigonometry, we can move on to triangles that have different measurements. So if I have, again, this SAS approximation here and I'm trying to figure things out, I know the base is 5, but I don't know what the height is. But I can use my knowledge of trigonometry to figure out what that height is. The height is always going to be an altitude of a triangle, so it's going to be a right angle. And so if I just look at, ignore the 5, if I just look at that part of the triangle, then I know that by definition the sine of 50 degrees is equal to the opposite over the hypotenuse. And so if I wanted to figure out what the height of the triangle, not h for hypotenuse, but the height of the triangle is going to be 4 times the sine of 50. So I can say the area is 1/2 the base times the base in this case would be 5 times 4 sine of 50. And that's going to give me what the area of this triangle is. And so I'll leave that up to you to put that in your calculator. But we get this formula that area in general for any triangle is going to be 1/2 b times c times the sine of a. And so again, what's a, b, and c? In this case, b is one side, c is the other, and a is the angle that's in between them. And so it would work if I did 1/2 4 times 5 times the sine of 50. If I switched to what b and c were, it wouldn't matter. As long as it's the included angle, then this formula for finding the area of a triangle works. This is not one that I per se would memorize. I just would know, hey, I need to do an application to find area that's 1/2 the base times the height. I know the base, I can use trigonometry to find the height.